Aluminum foil, a versatile and indispensable material in our daily lives, plays an essential role in the kitchen, packaging, and industry. The production of aluminum foil is a complex process that begins with the extraction of bauxite, a reddish-brown mineral from which aluminum is derived. Let's delve deeper into the fascinating world of aluminum foil production. And what are the key properties of aluminum foil? And why are medicines and dietary supplements often packaged with this shiny silver layer of aluminum? The first step in aluminum foil production begins with the extraction of bauxite, a reddish-brown mineral that typically contains around 15 to 25% aluminum oxide. Large-scale mining operations extract millions of tons of bauxite from the earth annually. After extraction, raw bauxite is transported to processing plants, where it is crushed into a fine powder. In the processing plant, the finely ground bauxite undergoes the Bayer process. About 4 tons of bauxite yield approximately 2 tons of aluminum oxide. The bauxite is mixed with sodium hydroxide, leading to the formation of sodium aluminate. This process results in a solution from which around 60% of aluminum oxide can be recovered. Subsequently, this solution undergoes a series of filtration and precipitation steps to achieve the desired aluminum oxide concentration. The aluminum oxide is then subjected to the Hall-Héroult process, an electrolytic process that globally produces approximately 60 million tons of aluminum annually. The molten cryolite electrolyte contains about 10 to 12% aluminum oxide. The process consumes significant amounts of electricity, with each ton of produced aluminum requiring approximately 15,000 kilowatt-hours of electricity. It yields pure aluminum with a purity of around 99.7%. The obtained aluminum blocks are heated to about 500 degrees Celsius and pressed through rolling, resulting in foil with a thickness of just a few millimeters. The hot rolling process consumes substantial amounts of energy, approximately 9 megajoules per kilogram of produced foil. The resulting aluminum foil rolls have a width of 800 to 1200 millimeters and can be several kilometers long. After hot rolling, the aluminum foil undergoes the cold rolling process, where the foil is passed between rollers at temperatures below 100 degrees Celsius. This process significantly reduces the thickness of the foil, with reductions of up to 90%. This allows the production of foil with thicknesses ranging from a few micrometers to several millimeters, depending on the intended application. To enhance the properties of aluminum foil, the surface is often treated. A thin coating of less than 1% of the total weight can be applied, such as a layer of varnish or a plastic film. These treatments serve as protection against oxidation and corrosion, and sometimes as an additional barrier against moisture. The weight of a standard roll of aluminum foil can vary from a few kilograms to tens of kilograms, depending on the application and thickness. After rolling and any surface treatments, the aluminum foil is cut into rolls according to the desired specifications. These rolls can vary in length with typical weights between 2 and 5 kilograms per roll. The packaging process is optimized for efficiency, with each roll carefully wrapped to prevent damage. Consumer-oriented packaging can vary in size, with rolls for household use, ranging from a few meters to commercial rolls of tens of meters. Stringent quality controls are also crucial to ensure that the product meets required standards and specifications. Some aspects considered in quality control include the consistency of the aluminum foil, thickness meeting manufacturer specifications, often measured using precise instruments. The foil must possess the required mechanical properties, such as tensile strength and elongation, to perform well in various applications. There should be no irregularities such as tears, holes, or other defects on the surface of the foil. The foil should have a smooth surface, without rough spots or bumps, important for proper processing and user experience. Aluminum foil is often used as a barrier against moisture, light, oxygen, and other elements. Quality control must ensure that the foil retains these barrier properties. If the foil is intended for use with food, it must comply with food safety standards, and no harmful substances should migrate to the food. In large-scale production, it's crucial that each foil roll is consistent in terms of specifications and properties. The packaging of aluminum foil must be protective, ensuring that the foil is not exposed to harmful environmental factors. Quality control can be conducted through visual inspections, measurements, laboratory tests, and other techniques, depending on the specific requirements and applications of the foil. It is an essential part of the production process to ensure that the end user receives a high-quality product. Aluminum foil is used for various purposes today, Most commonly, it is used to wrap and preserve food. It has properties that help maintain the freshness of food and protect it from light, air, and moisture. Aluminum foil is also used to wrap food during cooking or baking, such as preparing potatoes in the oven, wrapping fish for the barbecue, and so on. Sometimes, it is used for insulation purposes, applying it as a reflective material to bounce back heat or cold, for example, behind radiators to redirect heat into the room. In electronics, aluminum foil is sometimes used as part of electromagnetic shielding or to reflect signals. In the summer, aluminum foil is often used during barbecues to wrap food or as a base for delicate foods that might otherwise fall through the grates. The use of aluminum foil can vary depending on the region, cultural practices, and individual preferences. However, it's important to note that excessive use of aluminum foil in certain cooking conditions can lead to the migration of aluminum into food, so caution is advisable when cooking with aluminum foil. In recent decades, technological innovations have further improved the production of aluminum foil. Modern manufacturing plants use advanced automation and control mechanisms to increase efficiency. The application of advanced sensor technologies ensures accurate measurement of foil thickness and quality parameters during the production process. This allows manufacturers to strive for even thinner and lighter material while maintaining the required performance characteristics. Sustainability and environmental awareness are playing an increasingly important role in aluminum foil production. Manufacturers aim to reduce energy consumption by utilizing renewable energy sources and energy-efficient processes. Recycling of aluminum has become an integral part of the production cycle. Aluminum foil is fully recyclable, and recycling used foil requires only 5% of the energy needed to produce new aluminum. These sustainability efforts contribute to reducing the ecological footprint of aluminum foil. The versatility of aluminum foil has led to innovative applications in various industries. In the pharmaceutical sector, aluminum foil is often used for drug packaging. The foil's barrier properties protect medications from external influences, including light and moisture. Additionally, aluminum foil is used in the production of capacitors in the electronics industry due to its excellent conductive properties. Modern surface treatments of aluminum foil include nano coatings and special laminates. These advanced technologies not only enhance corrosion protection, but also provide antimicrobial properties, making aluminum foil suitable for applications in the food industry, where hygiene is crucial. Such innovations strengthen the position of aluminum foil as a material constantly evolving to meet the demands of modern applications. The history of aluminum foil dates back to the early 20th century, with Alcoa developing the first commercial production process in 1910. The use and production of aluminum foil have since grown exponentially, with millions of tons produced annually and global dissemination of the material. During World War II, aluminum foil played a vital role in military packaging, with tens of thousands of tons used. After the war, aluminum foil found its way into households, with new production techniques in the 1950s and 1960s. Cold rolling of aluminum foil opened the door to thinner and more flexible material without sacrificing strength. Today, aluminum foil has evolved into an indispensable material in various sectors, with advanced technologies and new applications continually being discovered. Post-World War II, the growth of aluminum foil continued steadily. In the 1970s and 1980s, further improvements in the production process were introduced, including advanced rolling and cutting techniques. The growing demand for lightweight, sustainable packaging materials in the food industry contributed to the enduring popularity of aluminum foil. Today, the annual global production of aluminum foil has risen to hundreds of thousands of tons. The evolution of aluminum foil reflects not only advances in production technologies, but also adaptation to changing consumer needs and technological developments. The material remains a crucial part of our modern society, with ongoing innovations expanding its scope of applications, whether packaging food, insulating buildings, or serving as a component in advanced technologies. Aluminum foil remains an indispensable material that continues to influence our way of life and production. Thank you for joining us on this journey from bauxite to aluminum foil. If you found this interesting, please like, share, and subscribe for more videos. Thanks for watching.